Alrighty, in today's video, we're going to be talking about 2.1, linear equations in one variable. All right, so majority of the stuff is just kind of teaching you how to solve equations in a pretty straightforward manner. Basically, you just do the opposite operation. So if you are trying to solve for x and you're multiplying, the opposite's division. If you're dividing, the opposite's multiplication. If you're adding, the opposite's subtraction. And then if you're subtracting, the opposite's adding. It goes a little bit further in. If you're square rooting, then the opposite's squaring. If you're squaring, the opposite's square rooting. Same thing with any nth root or nth power. And then it gets into some absolute value equations. It's kind of states that there's two possible answers, one possible answer, or no answers. And then we get into those infinitely many answers, no solution, or one answer as well. And just basically just gives you a whole bunch of different examples, but not too much like definition-based stuff. So with that, and word problems come back into play here in chapter 2. So I'm just going to kind of go into the questions and kind of just show you how to go about them on each one of them. So with that said, we're going to be on page 101, and I'm going to look at problem number 1. So it says -3 parentheses 2t minus 4, close parentheses, equals 7 parentheses 1 minus t. So when we're working through this, the very first thing you want to do is parentheses by distributing, which basically just means multiply to each term inside the parentheses. So -3 times 2t gives you -6t. And then -3 times -4 gives you that positive 12. Or two negatives make a positive. 7 times 1 gives you 7. And 7 times -t gives you -7t. Once you have rid of the parentheses, you want to get all of your variables to one side. Some teachers teach it to get all the letters to the left or to the right. I personally just like to move my smallest coefficient over so that I don't have to deal with negatives, but personally, it does not matter to me as long as you understand what your answer is going to be. So I guess in this situation, -7 is smaller than -6, so I'm going to get rid of the -7 by moving it to the other side. But to do anything, to get from anything from one side of the equal sign to the other, you must do the opposite operation. So the opposite of -7t would be to add 7t. And if I add 7t on the right side, I need to add 7t on the left side. What you do to one side, you must do to the other side. Now also notice I lined up my like terms so I didn't get confused and try to add it to non-like terms. This -7t plus 7t cancels out and it goes away. So I just have 7. And then -6t plus 7t gives me 1t, and I don't necessarily have to write the 1, plus 12. Now I don't have to deal with negatives, and now I can get rid of my plus 12. So now I'm going to subtract 12 on both sides again. But you do to one side, you must do the other again, lining up like terms. 12 will cancel out. I'm left with t, and then I see that 7 minus 12 gives me -5. Okay? And that's pretty much it on those type of problems. Let's try lots more. Let's look at number 4. 4 says 3x plus 5 equals 3 times x plus 3 minus 4. So in this situation, again, got to get rid of that parentheses. That's always your first step. So I'm going to rewrite the left side because that's good to go. Distribute on the right side. But notice I only distribute to the x and 3. The -4 was not in parentheses, and I will not distribute the 3 into it. Only the stuff inside the parentheses. So 3 times x gives me 3x. 3 times 3 gives me 9. And then drop down to -4. After this, before I get the x to one side, I do want to combine like terms. So I'm going to combine my 9 minus 4. So I drop down my 3x plus 5. Drop down my 3x. 9 minus 4 gives me positive 5. At this point, you can stop or you can keep going. But if you can realize that the left side equals the exact right side, we will basically just say all real numbers. I guess I'll spell it out for you. Or a little bit cleaner, we can write the real numbers symbol, which is the bolded R, which again, just to give you a slowdown how to write that, 2 lines parallel, then draw your R from the back of the L or the parallel, then come back, end it at the second one, and then bring it down. So that's like a bolded R. This is kind of what it's a little bit easier to write or find the symbol for, and then that's it. If you didn't realize that, if we kept on going, we just say I was blind and noticing. All right, sorry about that. Lost my connection there. All right, so I would just subtract 3x because they're both the same number, and I would see that they cancel. Left 5 equals 5. Hopefully you stop there. At this point, you're like, all right, 5 equals a true statement, so therefore all the answer must be all real numbers. All right. So again, you can notice it here, or eventually you'll get to a point where it's the same number. If you subtracted 5 on both sides, you get to 0 equals 0. You would still end up with a true statement. All right, let's look at other different types. Let's look at number 7. 7, we have 4s minus 3 over 2 plus 7 over 4 equals 8s plus 1 over 4. Now, there's a couple ways to these type of problems. These are rational equations. I could make sure they all have the same denominator, work at it that way. But because it's an equal sign, that means it's an equation, not an expression, I can actually get rid of the fraction. And the way you can get rid of it is just ask yourself, what is the least common denominator between 4 and 2? Now, hopefully this is pretty simple, but if not, break it down into its prime factorization. 4 breaks down into 2 and 2 is just 2, right? That would mean that they have 1, 2 in common, and then a second 2 not in common. So therefore, you would say 2 times 2 is 4 is their least common denominator. Now, you might be able to just easily see that, but I wanted to break it down so you could see it on a harder scale. So you take that least common denominator 4, and you're going to multiply to each fraction. Now, what happens is if I take 4 and I multiply it to this fraction, 2 goes into 4 2 times. So therefore, I'm really going to multiply this guy by 2. So I'll rewrite it. So again, least common denominator is 4, but 2 goes into 4 2 times. So I'm really multiplying this by 4. On a side note here, this is what it would look like. You would say 4 times 4s minus 3 over 2, and then 2 can go into 4 2 times. So what we're doing is we're just kind of saving this step and going straight here. Over here, 4 goes into 4 1 time, so therefore there is no more 4, and it's a 7. Same concept as a side note here. 4 times 7 over 4, the 4s would cancel and you'd be left with 7. So we're pretty much doing this sign stuff right away. So again, 4 goes into 4 1 time, so I'm just left with 8s plus 1. By doing that, we now have an equation with no fractions. Makes life a little bit easier. So now what I'll do is what I was doing earlier. I'd get rid of my parentheses. So I distribute. 2 times 4s is 8s. 2 times negative 3 is negative 6 plus 7 equals 8s plus 1. Combine like terms. I'll combine these. So 8s, negative 6 plus 7 would be plus 1. and then I get 8s plus 1. All right, I didn't do that on purpose, but this happened again be the exact same equation on both sides. So the answer here would be all real numbers. All right. And what that basically means with these two here, it just means that any value s that you can think of, if I plug it in there, it's going to work. All right, let's look at number 11. This one is 6/7 times m minus 4 minus 11/7 equals 1. Again, not a big fan of fractions. So I'm going to multiply everything by the least common denominator, which in this case is 7 is the only denominator. So I'm going to multiply by 7. That makes life a little bit easier. So I'll multiply to this whole thing. This whole thing is one term. And then this one, and then this one. So when I do this as a single term, I can see that the 7s here would cancel, and I'd be left with 6m minus 4. And again, I'll write this out as a side note. When I distribute, there would be a 7 times 6/7 times m minus 4, just like that. And then I can see that those can cancel. All right. Here, I see the 7s cancel, so I have minus 11. Here, I have nothing to cancel, so I have to straight up multiply this one. So 7 times 1 would just give me 7. So then I would do 6 times m, which would be 6m. 6 times negative 4 would be negative 24. Oh, and then I wouldn't do the negative 11 because it's not in parentheses, so everything else just drops down. Combine like terms, so I get 6m. Negative 24 minus 11 would be, let's see, it's negative 35 equals 7. And then I'm now trying to get m by itself. So the opposite, you always want to get rid of your addition, subtraction first before the multiplication and division. So I'm going to get rid of my minus 35 by adding 35 on both sides. So 7 plus 35 gives me 42. And then now I'll divide by 6. So then, so then 6 goes into 42 7 times. And there you go. All right, let's look at another one. Let's look at 15. So we get 0.73x plus 0.42 times x minus 2 equals 0.35x. So just because it's decimals, we can't be afraid. Same process as with whole numbers. We're going to take, technically, I will say, if you don't like decimals, we can move this into whole numbers by going to the hundredths place. So we can multiply everything by 100, but decimals shouldn't be something that you're afraid of. So I'm going to keep it as decimals, and I'm just going to distribute. But if you are, multiply everything by 100 to get rid of the decimal in itself. So 0.42 times x would just be 0.42x, and then 0.42 times 2 would be 0.84, right? And then equals 0.35x. I'll combine like terms next. 7.3 plus 0.42 would be a 6. I mean, x. 3 plus 2 is 5. 4 plus 7 is 11. So there'd be 1 here. So you get 1.15. So again, 2 plus 3, you add technically the hundredths place, and then go to the tenths. And then that gives you 1.1. So you get a whole 1. Minus 0.84 equals 0.35x. Get all my x's to one side. Again, 0.35 is smaller than 0.15, so I'm going to subtract 0.35x on both sides. I guess technically 0.35. This right here gets canceled, but I still have a 0 as a placeholder. 0.84. And then 1.5 minus 3.5, so 15, 20, 80. Get 0.80x. And then now I'm just going to finish it off. So I'll add 0.84 to both sides. So then I get 0.80x equals 0.84. And then now I'll divide by 0.80. And I get x equal, let's see how far they want us to go with that. Right, they want you to go all the way. So on this one, I'd probably simply just say use a calculator. I can see that 0.80 will go in there at least one time, and then I would have 4/80ths left. But really and truly, it's probably type this into the calculator. 0.84 divided by 5. All right, so that's pretty good right there. So let's look into these absolute value equations. You have enough examples for those as well. Let's skip to number 26. So I have the absolute value of 3x minus 2 equals 5. So remember, absolute value is the distance from 0. So there's actually two numbers that 3x minus 2 could equal to be 5 numbers from 0. This right here, 3x minus 2, could equal 5. Like that whole thing could equal 5, and it would be 5 numbers from 0. But 3x minus 2 could also equal -5 because the absolute value of -5 is also 5. So there's where your two equations come from. In a general sense, once your absolute value is isolated and everything's to the right side, write the equation as is. And then the other equation, you would change the sign of everything not in the absolute value sign. After this point, you just solve each one. So I'm going to add 2 on both sides. So 5 plus 2 gives me 7, and then I'll divide by 3, and you can keep it as 7/3. All right, then we come on over here, add 2 to both sides. Here's the misconceptions. A lot of students think, oh, if this is 7/3, this answer will be -7/3. This is not ever the case. Well, I say that in very slim cases, if I didn't have any adding there, it could potentially be the case. Or subtracting. But I would add 2, and when I do that, I get -5 plus 2, which is -3. And then I'll divide both sides by 3. So then x would equal -1. So that would be your two answers. All right, so again, absolute values can have two answers, one answer, or no answers. Technically, there is also an infinitely many answers. And if we get to one like that, I'll definitely explain why. Actually, no, not with an equal sign. I'm thinking inequalities. So it could be two answers, one answer, or no answers. You can have infinitely many with inequalities. And when we get to that discussion in the next video, I believe, we'll talk more about that. All right, but let's look at number 27. So number 27, we have negative absolute value of 3y plus 5 plus 6 equals 2. So before I can split this fraction up, I need to isolate the absolute value. So I need to get rid of the plus 6 because we always get rid of the addition and subtraction before multiplication and division. So I'll subtract 6 on both sides. And then get negative absolute value of 3y plus 5. And then 2 minus 6 is -4. And then get rid of this negative, I'm just going to divide both sides by -1, or technically multiply both sides by -1. It really doesn't matter. If I get the absolute value of 3y plus 5 equals +4. All right, so again, now I'm ready to split this up into two separate equations. So 3y plus 5 equals 4, and 3y plus 5 equals -4. Because again, this answer can either equal 4 or -4 because both numbers are 4 numbers from 0. After that, we just work it out. So subtract 5. So I get 3y equals -1. And then divide by 3. So I get y equals -1/3. Same concept over here. Subtract 5. -4 minus 5 is -9. Divide that by 3. And I get y equals -3. So you have -1/3 and -3 as your final answer. All right. Alrighty, so let's look at different other kind of cases with absolute values. Let's jump to number 46. This is absolute value of 6y minus 3 equals the absolute value of 5y plus 5. All right, so two absolute values here equal to each other. Same type of process in a sense. This answer could be the positive version of this or the negative version of this. So you would have 6y minus 3 equals 5y plus 5. Looks like we did nothing to it. Or 6y minus 3 equals the negative version of 5y plus 5. Because again, both of this, if I plugged in this or this, I would still get the positive version of each. Therefore, after this point, now we just solve it. Again, I want to get my y's on one side. I'm going to move the smaller y, which in this case is 5y. And I don't like dealing with negatives if I can avoid it. 5y minus 5y cancels. Drop down my 5. 6y minus 5y is just 1y minus 3. And then now I'm going to add 3 to both sides. So I get y equals 8. Then do the same thing over here. 6y minus 3. Distribute this negative in. So I get negative 5y minus 5. And then again, negative 5 is still smaller. So now I'll add 5y on both sides. So now I get 11y minus 3 equals negative 5. And then I'll add 3 now to both sides. I get 11y equals negative 2. And then I'll divide both sides by 11. I get y equals negative 2 11ths. So I get 8 and negative 2 11ths as my answer. All righty, let's see what else. All right, other things that are in the section that I expect you to pick up as well is literal equations. So let's look at number 48. It says an ideal gas law, PV equals lowercase n RT, and it wants you to solve for T. All right, the way we do this is same process as with numbers. Realize that this NR here is multiplying to the T. So the opposite of multiplying would be division. But if I divide this side, I must also divide this side. By doing that, I now get T by itself. And this is it. That would be your final answer. You got T by itself. So with literal equations, you are solving the same way you do with numbers. The only issue is instead of getting a number as an answer, you just get another equation as the answer as well. All right. There's a few word problems I want to go through. So let's look at number 58. All right. 58 says two trucks leave a warehouse at the same time. One travels due east at an average speed of 45 miles per hour, and the other travels due west at an average speed of 55 miles per hour. After how many hours will they be 450 miles apart? All right. Well, anytime you see like miles per hour, things like that, that's like your rate. And if you remember with like y equals mx plus b concept, you have a slope, which is the rate. So I'm going to write out the first equation for the travel that's going due east. So that would be 45x, right? We're going to assume y is going to be 0 because it's the same spot for both. And then the second equation would be 55x to represent this travel that's going west. Then after that, we know that the total distance apart, total means to add, and then we know that they'll be 450 miles apart. So we just got to figure out how long of traveling at both of these speeds will I be going 450 miles. So in a different concept, you could say, well, 45 mile per hour guy goes 200 miles, and then 55 mile per hour guy goes miles. And that at that point, you now have gone 450 miles apart. So that's why you would just add the two. We don't know if that's going to be what it is, but that's kind of what the math looks like. All right. So once you get the setup, the math is really easy, but the setup is usually the hardest part. But 45 plus 55, that would give you 100x. And then I would divide by 100. And then I would see that x is equal to 4.5. Now, 4.5 is not my answer. Actually, yes, it is. Because I'm looking for after how many hours. Sorry, I assume that they want to know how much each person traveled, but that's not what the question. That question does say after how many hours will they be 450 uh, miles apart. So this will be 4.5 hours. So there you go. So do make sure you are answering the question. I just in my head thought they wanted to know what each person traveled, but they did not ask that. So I'm glad we went back and read the question again so we didn't do more work than we had to. All right, let's do another one. So you have plenty of examples. Let's look at 61. 61 says two brothers, Rick and Tom, each inherit $10,000. All right, so let's do this. So Rick, Tom, uh, Tom, both inherit $10,000. So they both get $10,000 each. Rick invests his inheritance in a savings account with an annual return of 2.25%, while Tom invests his CD paying 6.15% annually. How much more money does Tom have than Rick does after 1 year? So we just need to figure out what is 2.25% of 10,000 and have basically one of that. And then same thing here. So the best way to do this is I do 10,000 and I'll do 1 for the 100% of this plus the interest I got. The only issue a lot of students forget percents you have to turn into a decimal by turning it, moving the decimal places two places to the left. So I'm going to do 1 plus 0.0225. Right? And then whatever this result is will tell me the 10,000 plus the interest on top of it. A lot of other students, what they'll do is they'll do 10,000 times 0.0225, get the interest, and then add it to the 10,000. That's perfectly fine as well. I'm just doing it all in one move. So then same thing with Tom here. I would do 10,000 times 1 plus, move that decimal place 2 places. Oop, too many. 1, 2. So that'd be 0.0615. And so then we'll just plug it in. So this case would be 10,000. And then I'm going to go ahead and just add that up. So that'd be times 1.0225. So what I did there is this right here is 1.0225 to save myself some pen strokes. All right, so then that would give me $10,225. And then I'll do the same thing over here. I'll do 10,000 times 1.0615, and that would give me 10,615. The question is how much more money does Tom have? So now we just got to take 10,615 and subtract it from 10,225. And we get $390. Make sure you're using your units so that you know exactly what you're answering. All right, so there's that type. Let's look at another type. Let's look at number 67. Bob buys a large screen digital TV priced at $9,500, but pays $10,212.50. What is the rate of tax where Bob lives? All right, so this is pretty much a proportion problem. I'm going to start off with 9,500 on the bottom. It doesn't matter if you put it on bottom or top. I'm going to say this is equal to 100% of what the TV is. Taxes is what's added on top of the TV. So I know my price is $10,212.50, but I don't know what the new percent would be. So it'd be over 100. I just don't know what it's going to be. So then from here, and you can do it, flip it. You can say 9,500 over this. Just make sure it's 100 over your unknown. The best way to do this is you cross multiply. You multiply and then divide. So it looks like this. Now, again, I'm looking at this as 100, not 100%. So I don't have to worry about moving the decimal there. That's going to be 10,212.50 times 100 and then I'm going to divide that result by 9,500. And when I do that, I get 107.5. What that tells me is if I take 107.5 minus the 100 and get 7.5, this was the increased interest rate or tax rate on my TV. So in this, where Bob lives, he has an interest rate of 7.5%, not interest rate, tax rate of 7.5%. All right. Let's do one more, and I think you have all the examples that you'll need. So let's look at number 72. It says Kathy buys last year's best-selling novel in hardcover for $15.05. This is a 30%, lost my place, discount from the original price. What is the original price? So this is a 30% mark down. So that means that this is 15.05. And if it's 30% discount, that would mean that this is 70%. So then from there, I just need to know what is 100% if I'm trying to figure out what the original price is. So again, notice I'm lining up with what it relates to. So again, this is 30% discount. That means this is 70% of the original price. So that'd just be 15.05 times 100. And then I would divide that by 70. And so my answer here would be $21.50 was the original price of the book. All right, so not too hard on the word problems, but hopefully that's enough examples for you. As always, if you need more help, feel free to email me. Until the next video, bye for now.